Assalamualaikum and hello everyone. Welcome to the video for Chapter 4 Introduction to Organic Chemistry for 4.3 Classification of Organic Compounds. In this video, what we're going to learn is to define homologous series, explain the general characteristic of homologous series, and state the ability of carbon to form 4 covalent bonds with other carbon or other elements. So previously, we have learned the name of the functional groups. And then I have mentioned that the class or homologous series is different from the functional group. For example, if you have double carbon-carbon double bond in the structure, the class or the homologous series is alkene, but the functional group is carbon-carbon double bond. In this video, we're going to explain what is meant by the class or homologous series itself. So what is the characteristic? So on your notes, it will be on page 9. On page 9 here, there is a small section explaining about the homologous series. Okay, so what is homologous series? So the definition is a series of compounds whereby each member differs from the next member by a constant CH2 unit. So the first characteristic is that all members are represented by the same general formula. So first, let us look for the homologous series for alkane. It actually follows general formula. For the case of alkane is CnH2n plus 2. So that is meant by the general formula. So this is for the case of alkane. For the case of alcohol, the general formula is CnH2n plus 2 oxygen. So for example, what is meant by the general formula here for the alkane CnH2n plus 2? So carbon, for example, is if carbon is 1, hydrogen is 2 multiplied by 1 plus 2. It must be C1H4. Or if the carbon here is 2, is C is 2, the hydrogen is 2 plus 2 multiplied by 2 plus 2, which is C2H6. From here, we can see CH3, we have C, number of carbon is 2, and the hydrogen is 6, which follows the general formula of alkene. Okay, so that is for the case of alkene. For the case of alcohol, okay, so the difference is CnH2n plus 2O. So we have extra O. So here, if we have C is 1, H is still 4, but then we have O. So here for the case of methanol, C is 1, hydrogen is 3 plus 1, 4, and then O is only 1. Okay, so that is meant by the general formula. Okay, so the second characteristic is that all members have the same functional group and the same chemical properties. Okay, so from the previous video, we have learned that the alkane does not have any functional group. But for the case of alcohol, the functional group is hydroxyl. So I'm just going to add in the notes here. So the third characteristic is the successive members of any homologous series differ by a CH2 unit. So first let us look for the case of alkane. We have CH4, we have CH3. When we have 3 carbon, we have CH3, CH2, CH3. So it means that, okay, by the end, or successive means that the berterusan. Okay, so successive here, members of any homologous series, if we have this one is carbon 3, we have 3 carbon. If we have 4 carbon, we're going to add CH2 in the middle here. So if there is 4 carbon, it will be CH3, CH2, CH2, CH3. So if this is, we have 4 carbon. If we have 5 carbon, we're going to add another carbon with H2. So that is what is meant by the successive member of any homologous series differ by a CH2 unit. So here, if we have 5, it will be CH3, CH2, CH2. Okay, we can't have CH3 anymore. Okay, we're going to add one more. So when we're adding one more, it will be CH2, CH3. Okay, so this is for the case of alkane. If you're unsure, so let us look for the case of alcohol. The first one, we have CH3OH. Second one, we have CH3CH2OH. The third one, the third carbon, is we have CH3CH2CH2. We can see here, we have the addition of CH2. So here, it is meant by the successive member differ by a CH2 unit. When we're adding more carbon, it's actually we're adding CH2 some more. Okay, so from here we have only 2 CH2. When we have 4 carbon, it will be CH3, CH2, CH2, CH2 more, OH. So that's for 4 carbon. If 5, it will be CH3, CH2, 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 CH2OH. So that is what is meant by the successive member differ by a CH2 unit. So the last characteristic is that there is a gradual change in the physical properties. So it means that when the increasing number of carbon atom, it will change from gas to liquid to solid. So we have learned about the definition of homologous series and the characteristic of homologous series. Now we're going to learn about the ability of carbon to form 4 covalent bonds. Okay, why specifically about carbon? Because organic chemistry, again, is a study about organic compound containing carbon and hydrogen. So mostly we're going to focus on the carbon itself. Okay, so here I mentioned that carbon atom has 4 valence electron and can form 4 covalent bond to other atoms. Again, for the case of 4 covalent bond, it could be single bond, it could be double bond, it could be triple bond. So let us label the bond itself. So carbon can form 4 covalent bond to other atoms, again to make sure that it achieves octet. So it could be single bond, double bond, triple bond. So when you're drawing your carbon, okay, this is especially important when you're learning about alkene or alkene, make sure the maximum number of carbon is only 4. So for example here, for each carbon we have 1, 2, 3, 4. 4 single bond. This carbon also have 1, 2, 3, 4. 4 single bond. Okay, for the case of carbon-carbon double bond here, so carbon, because it has these 2 bond here, so it needs 2 more single bond. It has 1, 2, 3, 4. Still 4 bond. It's just that the difference here, it has 2 single bond and 1 double bond for this carbon. The same goes for this carbon. It has 1 double bond, 2 single bond. But in total, it's actually 4 covalent bond. And for the carbon-carbon triple bond, this one, again, 1, 2, 3 from the triple bond itself, and 4 is from the single bond. So this carbon can be attached to any other atom lah. It could be to the halogen, it could be to the halogen, which is fluorine, for example here bromine, iodine, chlorine, or this one hydrogen, or OH itself. It could be attached to any other atoms. For the case of double bond, it's actually not only we have learned about carbon-carbon double bond, for the functional group or the homologous series, we call it as alkene. We also have we have learned about the carbonyl, which is C double bond O. But then again, for the C double bond O, the carbon must have 4 bond. So here it only have 2, so 1, 2. So I'm just going to draw here for the case of carbonyl. Okay, so this is our carbonyl. Again, even though carbon has double bond here, it must have 4 bond in total lah. Last but not least, we also have learned the carbon-carbon triple bond, the name of the functional group, or the homologous series is alkyne. So that is all the videos about the homologous series and the ability of carbon to form 4 covalent bond.